Today we are going to learn fourth chapter. Today's goal is to solve the given problems that are 21 to 40. Let's start it. So what happens to the inertia of an object when its velocity is doubled? Here inertia is related to mass. Greater the mass, greater is the inertia. Either the body is at rest or the body is in motion, it doesn't matter. Inertia depends only on mass. If mass is not changed, inertia remains same. So when velocity is doubled, tripled, it doesn't matter. So inertia depends only on mass. That means the object's inertia is unchanged. So option 4 is the right answer. Let's go to 22nd question. A stone is tied to the middle of a string and suspended from one end as shown in figure. Here S is the stone and O is the point of suspension. If you give a sharp jerk at P, the string will. Let's see another look at the figure. Here is the point O. This is the stone, it is suspended. And here point. If you give a sharp jerk at P, what happens? This is the sharp jerk. Sharp jerk means suddenly. This motion is not shared by upper part of the string. That's why only at the point P the string will break. So the string will break at the point P itself. So option 2, this is due to inertia of rest. Inertia of rest. That means at the point P itself, no, here string is attached to stone. So below the stone, the string will break below the stone. So option 1 is the right answer. Option 1 is the right answer. Let's go to 23rd. A loaded transport truck with a mass of 38,000 kg is traveling at 1.20 meter per second. What will be the velocity of a 1200 kg car if it has the same momentum? So my dear children, truck and car. So truck mass 38,000 kg and velocity 1.20. So truck mass and mass of car are different. So, but momentum should be same. That means momentum of truck is equal to momentum of car. So already we know very well momentum is equal to mass into velocity. In the place of momentum, write mass into velocity. This is for truck and this is for car. Right. Mass of the truck 38,000 into velocity of the truck, that is 1.20, equal to mass of the car, that is 1200, and velocity of car. Here two zeros gets cancelled. So point after here 10 gets cancelled. This is 38 into 12 is equal to 12 into velocity of car. 12 gets cancelled. Velocity of car equal to 38 meter per second. So option 2 is the right answer. Next go to 24th question. The impact which a body can produce due to combined effect of mass and velocity. So the impact due to combined effect of mass and velocity is called momentum. I already know momentum is nothing but the total amount of motion contained in a body is called momentum. It depends on mass and velocity, that is momentum. So 24 to 1, option 1 is the right answer. Let's go to 25th question. A body P has mass 2m and velocity 5. Another body Q has mass 8m and its velocity mass. A body P has mass 2m, velocity 5. Another body of mass 8m and velocity, this is here, velocity is missing, that is 1.25 v. Then ratio of momentum of P and Q is, here momentum of P by momentum of Q is equal to mass into velocity of body P by mass into velocity of body Q. That mass of P, that is 2m, velocity, that is 5v, by Mass of Q is, that is 8 m, into velocity is 1.25. So 2 m into 4. So this is 1.25 into 4. So 4 gets cancelled, that is equal to 1:1. So 25th one, second option is the right answer. Let's go to 26. 26th question. An electron of mass 9 into 10 power of minus 31 kg is moving in a straight line path with a velocity of 6 into 10 to the power of 7 meter per second. The momentum of electron is, we know very well, momentum is equal to mass into velocity. Here mass of the electron is 9 into 10 to the power of minus 31 kg into velocity, that is 6 into 10 to the power of 7 meter per second. That is equal to here 9 into 6, that is 9 6 are 54. 54 into 10 power of minus 31 plus 7, that is equal to minus 24. This we can written as 5.4 into 10 power of minus 23 kg meter per second, we can written as Newton second. So 5.4 into 10 power of minus 23. So option 1 is the right answer. Let's go to 27th question. A particle of mass m is executing a uniform circular motion along a circular path of radius r. If the magnitude of its linear momentum is p, the centripetal force acting on the particle is. Centripetal force means it acts towards the center of the circle. Already we know very well centripetal force equal to mv square by r. So relate the centripetal force with the momentum. We know very well momentum is equal to mass into velocity. So multiplied and divided with m. Then it becomes mv whole square by mr. It is equal to p square by mr. So this is a relationship between centripetal force and momentum. F equal to p square by mr. Option 4 is the right answer. Next go to 28th question. A body is moving with a constant momentum. The motion of the body is. Here momentum means we know very well mass into velocity. So mass is a scalar quantity. Velocity is a vector quantity. Vector quantity. Here momentum is also a vector quantity. So momentum is constant means its magnitude is constant and direction remains same. So that means velocity should be constant and direction remains same. So constant momentum means the motion of the body is uniform motion. That motion of the body is uniform motion and the body is moving with uniform velocity. So uniform velocity. Option 1 is the right answer. Next go to 29th. A body of mass m collides against a wall with a velocity v and retraces its path with the same speed. The change in the momentum is. Here, consider this is a ball of mass m and its velocity is v. Retraces its path. See, retraces along the same path after collision with the same speed v. Here, consider right, this direction is taken as positive and this direction is taken as negative. So this is the initial momentum. Initial momentum is equal to mass into plus v. This is the final momentum. Final momentum is equal to mass into minus v. Already we know very well change in momentum is equal to final momentum minus initial momentum, that is equal to minus mv that is equal to minus 2 mv. This is the change in momentum. But if only magnitude, that is equal to 2 mv. So 2 mv is the right answer. So option 2 is the right answer. Next go to 30th question. A goalkeeper in a game of football pulls his hands backwards after holding the ball shot at the goal. This enables the goalkeeper to. See, already we know very well while catching a cricket ball, the cricketer lower his hands. Why the cricketer lower his hands means we know very well. According to Newton's second law of motion, F net equal to rate of change of momentum. As time increases, net force acting on the hands decreases. That means to reduce the force exerted by the ball on hands. That's why he lower his hands and his hands are backwards. What is the reason behind it? Means it is due to as time increases, it reduces the force exerted by the ball on hands. So option 2 is the right answer. Today's goal is to solve the given problems that are 31 to 40. So 31 question. In SI units, a force is numerically equal to when the force is applied to it. We know very well SI unit of force is Newton. We know very well according to Newton's second law of motion, F net is equal to mass into A net. So the SI unit of force is Newton. The SI unit of mass is kg. The SI unit of acceleration is meter per second square. So if numerically the SI unit of force is 1 Newton means the mass should be 1 kg and acceleration should be 1 meter per second square. So when the force is applied to acceleration of 1 kilogram object. So option 3 is the right answer. Next go to 32nd question. A body of mass 2 kg moving with a speed of 100 meter per second hits a wall and rebounds with the same speed. If the contact time is 1 by 58 seconds, the force applied on the wall is. Consider it is a wall. A body of mass 2 kg is moving with a speed of 100 meter per second. Rebounds with the same speed, that is 100 meter per second. The force applied on the wall is. Consider this is the initial velocity, this is the final velocity. This direction is taken as positive and this direction is taken as negative. We know very well net force is equal to mass into net acceleration. So in the place of acceleration, we can write acceleration equal to rate of change of velocity, that is v minus u by t. So in the place of mass, write 2 kg, that is final velocity, that is minus 100 meter per second minus initial velocity, that is 100 meter per second, by time taken is 1 by 50th second. So that is equal to 2 into minus 200 minus 100 minus, that is equal to minus 200. 50 comes into numerator. That is equal to 2 into 2 4, 4 into 5, that is 20 into 10 power of 3 Newton. We can write 2 into 10 power of 4 Newton. So 2 into 10 power of 4 Newton is the right answer. Let's go to 33 question. A cricket ball of mass 150 gram moves at a speed of 12 meter per second and after hitting by the bat, it is deflected back at the speed of 20 meter per second. If the bat and the ball remained in contact for 0.02 seconds, then the impulse and average force exerted on the ball by the bat are respective. Here we can write average force. First of all, write average force equal to mass into net acceleration. So your mass is given in gram, convert into kg. So in the place of gram, write 1 by 1000 kg. Acceleration equal to rate of change of velocity, that is v minus u. The final speed is v, initial is u. It is deflected back here, it is deflected back. So this is 12 meter per second and this is 20 meter per second. Consider this is positive, this is negative. This is the initial speed, this is the final speed. The final speed is minus 20 minus initial speed is 12 by time of contact. The time of contact is 0.02 seconds. So my dear children, 150 into 1 by 1000 minus 20 minus 12, that is minus 32 by this is as 2 into 10 power of minus 2. So these two zeros gets cancelled, 0 gets cancelled. Clear? Then 2 1 ja 2 16. So 15 into 16. 15 into 16, 15 into 16, 6 5 ja 30, that is 9, 1 5 ja 5, 1 1 ja 1, 0 and 10, 14. That is 240 Newton. So average force is 240 Newton. Next, impulse. We know very well. Impulse is equal to force into time. That is average force into time. Your average force is 240 Newton and time of contact is 0.02 seconds. So 0.02 seconds. You can written as 240 into 2 into 10 power of minus 2. That is 480 in 10 power of minus 2. So that is equal to 4.8 Newton seconds. So impulse is 4.8 Newton seconds and average force is 240 Newton. So option 3 is the right answer. Let's go to 34th question. Here 34th question. So here velocity versus time graph of a ball of mass 50 gram rolling on a concrete floor is shown in figure. The ball comes to rest due to frictional force of the floor acting on it. This frictional force of the floor on the ball is, you know very well, friction, nothing but force. Force according to Newton's second law of motion. Net force equal to mass into net acceleration. Here velocity time graph. Already we know very well. Slope of velocity time graph. Slope of velocity time graph gives acceleration. So acceleration. So here slope is equal to acceleration. So calculate slope 0 to 8 seconds. That is it. Rate of change of velocity delta v by delta t for 8 seconds. For 8 seconds here, this is the initial velocity, and after 8 seconds its velocity becomes 0. That is v equal to 0. So we can write 0 minus 80 by time taken is 8 minus 0. That is equal to minus 10 meter per second square. So acceleration is minus 10 meter per second square. In the place of mass, write 50 gram. Convert gram into kg. So in the place of gram, 1 by 1000 kg. In the acceleration is minus 10 meter per second square. 0 0 0 0 gets cancelled. Then 5 1 the 5 2 the, that is equal to 1 by 2. 1 by 2 is equal to 0.5 Newton. So 0.5 Newton is the right answer. Next go to 35th question. A force of 5 Newton produces an acceleration of 8 meter per second square on a mass m1. So consider this is a mass m1, a force of 5 Newton. It produces an acceleration of 8 meter per second square. Then add an acceleration here. Consider another mass m2, same force 5 Newton. It produces an acceleration of 24 meter per second square. So what acceleration in meter per second square would the same force provide if both the masses are tied together? If both the masses are tied together, that is m1 plus m2, same force 5 Newton, then calculate acceleration. So we know very well. So first calculate here m1. M1 we know very well, F equal to ma, from this m is equal to F by a. So m1 equal to, we can write F by a, here F is 5, acceleration is 8. Then m2 is equal to, force is 5, acceleration is 24. So here m1 plus m2, m1 plus m2, right here m1 plus m2 is equal to 5 by 8 plus 5 by 24. So 8 24 LCM, that is equal to 24. 8 3 ja, that is 5 3 ja, 15 plus 5, that is equal to 15 plus 5, that is equal to 20 by 24. So m1 plus m2 is equal to, m1 plus m2 is equal to 20 by 24. Then here force is 5 Newton and calculate the acceleration. We know acceleration equal to net force by total mass, that is m1 plus m2. Here net force is 5 Newton by m1 plus m2 is 20 by 24, that is equal to 20 24. 5 1 ja 5 4 ja 4 1 ja 4 6 ja. So acceleration is equal to 6 meter per second square. 6 meter per second square is the right answer. So option 4 is the right answer. Let's go to 36th question. A constant force acts an object of mass 5 kg for a duration of 2 seconds. It increases the object velocity from 3 meter per second to 7 meter per second. When a constant force acts an object of mass 5 kg, say constant force for a duration of 2 seconds. 2 seconds. The object velocity is 3 meter per second. So it increases velocity 3 meter per second to 7 meter per second. If the force was applied for a duration of 5 seconds, what would be the final velocity of the object? So here, first calculate force. We know very well, according to Newton's second law of motion, F net is equal to mass into A net. Mass into A net. So in the place of mass, that is 5 kg into A net. A net means acceleration. Acceleration equal to rate of change of velocity. This is initial velocity. This is final velocity. So we can write 7 minus 3 by 2. So from 5 into 7 minus, that is 4. 4 by 2. 2 1 2 2. That is equal to 10 Newton. So your force is 10 Newton. Then apply here. Mass 5 kg. So here this time initial speed is 3 meter per second. The force is 10 Newton, but the force acting on the object 5 kg, this time the time duration is 5 seconds. Then what is the final velocity? Same formula, F net is equal to mass into, in the place of A net we can write V minus U by T. So from this we can write F into T by M is equal to V minus U. So calculate here, in the place of F10, time duration is 5, in the place of mass 5. 5 gets cancelled, 10 equal to V minus U. So 10 V minus, in the place of U, that is 3. So minus 3 comes this side, plus 3, 10 plus 3 equal to V, that is V equal to 13 meter per second. So 13 meter per second is the right answer. Let's go to 37th question. A bullet, 37. A bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeters. So what is the average resistive force exerted by the block on the bullet? Consider it is a wooden block, a bullet, okay, with a speed 90 meter per second. So it is stopped after a distance of 60 centimeter. So your initial speed is there, after 60 centimeter it stops. That means final velocity becomes 0. So calculate the resistive force. We know very well resistive force F net is equal to mass into A net. So calculate A net by using third equation of motion, that is V square minus U square equal to 2AS. Final velocity becomes 0. 0 minus initial is 90, square is there, so 90 into 90 is equal to 2 into A. S is 60 centimeter. Convert centimeter into meter. In the place of centimeter we can write 1 by 100 meter. So 0 gets cancelled. So 2 1 ja 2 5. 5 comes this side. My 5 into 90 into 90 is equal to A into 6. 6 comes this side. That is 6 1 ja 6 36. So that is acceleration equal to 5 into 15 into 90. Then substitute here F net equal to, in the place of mass 0.04 kg. So So we can write 4 into 10 power of minus 2 into, in the place of acceleration, 5 into 15 into 90. From this F net is equal to, so here this 0, here 1 0 gets cancelled. 4 into 5, that is 20, equal to 10 power of minus 1 equal to 15 into 9. So we can write 0, 10 power of 9 gets cancelled. That is 2 into 15, that is 30 into 9. 30 into 9, that is 270 Newton. 270 Newton is the right answer. Option 4. 37, option 4 is the right answer. Let's go to 38. 38th question. A ship of mass 3 into 10 to the power of 7 kg initially at rest. Initially at rest means u equal to 0. Is pulled by a force of 5 into 10 power of 4 Newton to a distance of 3 meter. Assuming that the resistance to water is negligible, the speed of the ship becomes. So here initially the ship is at rest. It is pulled by a force. Consider a ship. The ship is pulled by a force of 5 into 10 power of 4 Newton. The ship mass is given 3 10 power of 7 kg and the ship moves a distance of 3 meter. Clear, my dear? Then write according to Newton's second law, F net equal to mass into A net. So your mass is given. So in the place of A net, you can write rate of change of velocity. But here distance is mentioned. So go to third equation of motion, that is v square minus u square equal to 2as. So here v square, initial velocity is 0. 2 into a into, in the place of s, that is 3 meter. 3 meter. So from this a is equal to v square by 2 into 3, that is 6. 2 into 3, that is 6. So acceleration equal to v square by 6. So right here v square by 6. So that is F net. So F net is given, that is 5 into 10 power of 4 Newton equal to mass is given 3 into 10 to the power of 7 into v square by 6. That is 3 on the 3 2. If 2 comes this side, 2 into 5, that is 10. 10 into 10 power of 4 equal to 10 power of 7 into v square. So 10 power of 4 plus 1, 10 power of 5, 10 power of 7 gets cancelled. That is equal to v square equal to 1 by 10 power of square. V is equal to 1 by root 10 power of 2, that is equal to 1 by 10. 1 by 10 equal to 0.1 meter per second. So 0.1 meter per second. 38, option 3 is the right answer. Let's go to 39. A vehicle of mass 100 kg is moving with a velocity of 5 meter per second. To stop it in 1 by 10th second, the required force in opposite direction. Consider this a vehicle and force is acting in opposite direction. So what is the force required? So F net equal to mass into A net. So here A net, use velocity is given, it to stop it in 1 by 10 seconds. So use first equation of motion. From this we can write A equal to change in velocity by time taken equal to stop means final velocity becomes 0, u initial velocity is 5, time is 1 by 10. Then 10 comes into numerator, that is 5 into 10, that is 50 meter per second square. Substitute here mass 100 kg into 50 meter per second square, that is equal to 5000 Newton. So 39th, 5000 Newton is the right answer. Option 1 is the right answer. Let's go to 48th question. A force of magnitude F acts on a body of mass M. The acceleration of the body depends upon. So already we know very well, if greater the mass, if same force acts greater the mass, the acceleration is less. So acceleration is related to mass according to Newton's second law of motion. So the acceleration depends on mass of the body. So that is option 4 is the right answer.